Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Adjie Buanafijar. I'm going to present you my research proposal with titled Stock Return Modeling based on broker summary data using vector autoregressive. This research is supervised by Dr. Anwar Fitrianto, MSc, and Dr. Agus Muhammad Soleh, MT. Here is the outline of my proposal. It starts with research background, literature review, data, methodology, and the last is references. Okay, so the background is in the year of 2020, Indonesia Stock Exchange, or IDX for short, stated on its press release that there is an increase in number of investors. The increase is 53.47% than the previous year. This is twice than what was expected by IDX. Along with that statement, IDX emphasized that this increase should be followed by massive education about investment products. This research will focus on one product, which is stock. Important point of stock education is the analysis that helps us to choose whether to invest on which company. The most common types of analysis is technical and fundamental analysis. Technical analysis is focusing on predicting stock return in the future based on geometrical or mathematical pattern from only the prior return data. While the focal point of fundamental analysis is on evaluating companies' performance data that is available within the span of quarterly or yearly period. Regardless of the above analysis, supply and demand is what determine the price according to Person 2004. Supply and demand on stock market can be seen through the order flow. How many people buy and sell certain stock obviously will have an effect on stock price. In this research, the supply and demand data are represented by the net amount of buy and sell by multiple institutions or brokers. There are a lot of previous research that studied about the relationship of order flow and stock return, which will be covered on the literature review. Now, based on that background, the objective of this research is to model the stock return based on broker summary data. There have been a lot of research regarding this topic. On 2004, a study conducted by Chai and Zheng resulted that institutional order flow appeared to be correlated with stock return on quarterly time frame. And then Campbell et al. On 2005 provided evidence that there are daily covariances between institution portfolio flows and stock returns. Based on previous research, statistical methods that often being used for this case is vector autoregressive, or VAR. It is often used for its flexibility in terms of free parameters. Bose et al. 2017 applied VAR to elucidate underlying causal mechanisms in the time series for nursing research. And then Subramaniam on 2006 used VAR to explore intertemporal associations between market liquidity, returns, and order imbalance. The overall conclusion is there are persistent cause effects on those variables. There's also research that applied VAR involving similar variables, which is liquidity and trader factors, order imbalance, volatility, and returns. The result is there are significant bidirectional relationship of variables based on VAR with two legs, which also happen to Granger cause each other. This research is conducted by Cordia et al. On 2003. Then on 2007, Cordia et al. Released another research whether stock return of large capitalization companies will have an effect on the small capitalization ones. This problem is also modeled by VAR with Akaike information criterion as a criteria to determine the leg length. In the conclusion, they found out that the return of large cap companies do affect on the return of the small cap ones. Okay, for the literature review, the first one is order flow. It is an important part of the market microstructure. It is a measure of buying and selling pressure, net amount, net of buy-initiated orders and seller-initiated orders, according to Evans and Lyons on 2002. And the data that being used in this research is presented in the form of broker summary that is released at the end of the trading. On the right-hand side is the illustration of the broker summary. It is taken from the website from the data is obtained from one of the brokers in Indonesia, which is Indo Premier. The data contain amount of buy and sell from every broker that is represented by two character codes such as PD, CC, YP, etc. The next one is vector autoregressive. It is a statistical method that is used for analyzing the intertemporal effect in multivariate problem. It is widely used in the econometrics because of its flexibility. VAR is a combination of multiple autoregressive models according to Warson et al. 2017. Here's the general equation for VAR with like P. The third one is augmented decay-failure test. It is a method to test for stationarity, which includes more legs than the casual decay-failure, in order to extinguish autocorrelation, according to Mustab 2011. Here is the autoregressive equation with constant and trend, in which we will get the gamma value that will be used to decide whether a series is stationary with such hypothesis. Next, AKIK information criterion. This matrix is measure of goodness of fit for model. The usage of AIC in this research is to select the leg length according to Lotkapol 2005. The AIC value is equal to twice the number of parameters in the model, notated by M, minus 2 the log of the likelihood function, notated by L, according to Makridakis et al. 1998. And then Granger causality test. It is a method to test causal correlation between two variables. Here are the instances for the equation. The data used in this study is a time series data from January 2017 to July 2021 with total 1,130 trading days or observations. The companies are as follows. It consists of 5 companies from 5 different sectors that is consistently included in the list of most liquid stock by IDX. For each stock, the data structure consists of 4 variables. The dependent variables is the daily return in percentage, and the 3 explanatory variables are the amount of net transaction by each broker. The daily percentage return is chosen because it is more likely to be stationary rather than the price itself. And we know that price tend to have trend, which is not what we expect for stationary data. Here's the analysis procedure. It begins with trend test split, then the test for stationary will be performed. If the series turns out to be not stationary, then the data will be transformed until it becomes stationary. The procedure continues with Granger causality test to see the causal relationship. And then the leg length is selected based on AIC. After leg length is obtained, then there will be cross-validation with sliding window method. Next, model evaluation on the test data to assess how well the model performed on unseen set of data. The final step is to forecast the stock price on the 5 companies for 2 months period ahead. The first step, trend test split. The proportion is 80% as a training set and 20% as a test set. This procedure performed on the very first step in order to prevent data leakage from the test data. To train the data, this step is expected to improve the test data to really simulate real-world unseen data. The splitting mechanism is, of course, will not be done randomly. The first 80% sequence of the data is the training, and the rest 20% is the testing set. Next, for the stationarity using. Next, test for stationarity using augmented decay-failure test. In a simplified term, stationarity means the data must be horizontal along the line and fluctuate around constant mean and variance without any seasonal pattern. Cited from Makridakis et al. 1998. The test will be applied on all 4 variables. The third step is to test whether each variables are Granger causing each other. As we know, VAR is based on basic principle that one series has a temporal effect on another series. Before constructing the model, this causal relationship can be confirmed by Granger causality test. After we get the picture of how the causal relationship of all the variables, the next step is to select leg length. The next step is to select leg length by fitting multiple models with various numbers of legs. A good criteria for this purpose is to choose the model with the least AIC value, according to Lotka-Poll 2005. Step number 5 is cross-validation with sliding window method. This method is a specific type of cross-validation for time series. As an illustration, on the right-hand side, the data will be divided into 8 folds with total 4 iterations of first validations. On each iteration, the earliest fold will be taken out and replaced with the test set on the previous iteration. The evaluation metrics are mean absolute error and accuracy score. The best model obtained from previous steps then will be applied to forecast the testing set. The purpose is to see how well the model predicts unseen data. The evaluation metrics are mean absolute error and accuracy. You can see the equations on the right-hand side. For accuracy, the data will be binarized into 0 and 1, 0 for negative or 0 return, and 1 for positive return. The final step is to forecast the stock return for 2 months period ahead. Here are the references for this research. Thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.